Let f of x be equal to 1 half x to the third plus 3x minus 4. Let h be the inverse of f. Notice that f of negative 2 is equal to negative 14. And then they're asking us, what is h prime of negative 14? And if you're not familiar with how functions and their derivatives relate to their inverses and the derivatives of the inverse, well, this will seem like a very hard thing to do. Because if you were tempted to take the inverse of f to figure out what h is, well, it's tough to figure out the inverse of a third degree polynomial defined function like this. So the key, I guess, property to realize, or the key truth to realize, is that if f and h are inverses, then h prime of x is going to be equal to, 1 over f prime of h of x. 1 over f prime of h of x. And you could now use this in order to figure out what h prime of negative 14 is. Now, I know what some of you are thinking, because it's exactly what I would be thinking if someone just sprung this on me, is where does this come from? And I would tell you this comes straight out of the chain rule. We know that if a function and its inverse, that f of the inverse of our function, so f of h of x, we know that this is going to be equal to x. This comes out of them being each other's inverses. We could have also said h of f of x will also be equal to x. Remember, f is going to map, or h is going to map from some x to h of x, and then f is going to map back to that original x. That's what inverses do. So that's because they are inverses. This is by definition. This is what inverses do to each other. But then if you took the derivative of both sides of this, what would you get? Let me do that. So if you take the derivative of both sides of this, d dx on the left-hand side, d dx on the right-hand side, and I think you see where this is going. You're essentially going to get a version of that. The left-hand side, use the chain rule. You're going to get f prime of h of x, times h prime of x, comes straight out of the chain rule, is equal to the derivative of x is just going to be equal to 1. And then you divide both sides by f prime of h of x, and you get our original property there. So now with that out of the way, let's just actually apply this. So we want to evaluate h prime of negative 14 is going to be equal to 1 over f prime of h of negative 14. h of negative 14. Now, have they given us h of negative 14? Well, they didn't give it to us explicitly, but we have to remember that f and h are inverses of each other. So if f of negative 2 is negative 14, well, h is going to go from the other way around. If you input negative 14 into h, you're going to get negative 2. So h of negative 14, well, this is going to be equal to negative 2. Once again, they are inverses of each other. So h of negative 14 is equal to negative 2. And once again, I just swapped these two around. That's what the inverse function will do. If f goes from negative 2 to negative 14, h is going to go from negative 14 back to negative 2. So now we want to evaluate f prime of negative 2. Well, let's figure out what f prime of x is. So f prime of x is equal to, we're just going to leverage the power rule. So 3 times 1 half is 3 halves times x to the 3 minus 1 power, which is just the second power, plus the derivative of 3x with respect to x. Well, that's just going to be 3. And you could view that as just the power rule. If this was x to the first power, 1 times 3, x to the 0th power. Well, x to the 0 is just 1, so you're just left with 3. And the derivative of a constant, that's just going to be 0. So that's f prime of x. So f prime of negative 2 is going to be 3 halves times negative 2 squared is 4, positive 4. So plus 3. So this is going to be equal to 2 times 3 plus 3. So 6 plus 3 is equal to 9. So this denominator right here is going to be equal to 9. So this whole thing is equal to 1 over 9. So this involved, this isn't something you're going to see every day. This isn't a typical problem in your calculus class. but it's interesting.